Why would you apologize?
Well, because it's going to be hard to see, I think, especially the more I erase it.
But is that your fault?
Well, kind of. I brought you here.
But
I'm not going to pass the ball to somebody else. It's my fault. Let me own it. So here's the first thing I want to try right now. First thing I want to try. Can you guys see this okay?
yeah.
Let me entertain some guesses as to how fast I was going when I crossed the 200-foot marker. Right? My 200-foot group was over here, I believe, yes? You guys, the 200-foot group, excellent. When I went by them, entertain some guesses how fast I was going. Randall, go ahead. 12 miles an hour. Love it. I'm assuming that's miles an hour, yes? Not like feet per second or something.
Yes.
12 miles an hour. Let's just go with miles an hour. Anybody else? 20. Now, Randall was at 175, and you were at, where were you?
25.
You were 25 feet, so he went up the hill, watching me go away. It gets tougher to approximate that, obviously, the further away you are, especially looking at me going in a straight line away from you. Einstein wrote a wonderful paper about this, you may have heard about it, relativity.
Yes.
So, very, very wonderful idea of the apparent difference in speeds as the angle of the observer changes. Quite interesting, quite interesting. 12, 20, any other guesses?
8.
8? Love it, 8. Fantastic. Anything else? 4.
7.
7.
15.
15.
63.
69. Bingo! It's a combination of my lock and Osama. How did you do that? Throw it out there. 110. 88 miles per hour. So the idea
Is it possible to have a fraction?
of course it is. I would imagine it would be fractional. Much like when I asked, when you're checking your speedometer on the highway to make sure you're not speeding, most likely you are going a fractional speed as well. And you think about it. Think about your speedometer broken up into speeds from 0 to whatever it's 100, 0 to 100. There are 101 markings on that from 0 to 100. There are infinitely many, that was a strange accent, infinitely many numbers between 0 and 100. So it's much more likely that you're at one of those infinitely different values than you are at the exact. That's why it makes such a big deal when you guys said it was like exactly 8 or something. It's like exactly 8? Holy crap. Because it's much more likely that I'm a fractional value. So these are rounded off to the nearest whole mile per hour, which I love. I love that, by the way. Because usually the policeman that pulls you over doesn't say, oh, I'm nailing you for going 63.14 repeating in a 52, or something like that. You know, you're going 65 and it's 52 or whatever the speed is. So yes, I would think it would be fractional. The question is, can we derive from my data how fast I was going? And the answer is yes, if we look at it a certain way. The first thing we have to decide what it is. What is it? Let's put the data back up, because we have to clean it up. Oh, Randall, go ahead, please.
How far away was it?
200 feet from bottom to top.
And how, pretty much the time it took to get from here to there.
Say that again.
The time it took to get from here to there and convert that in miles.
I love that. Hold that thought. Give me like 5 minutes. Let's clean the data up first before we get into the... Say it again. I'm thinking it might not even take 5. If that's okay with you. So here's the data again. Now, what I did while you guys were taking your 5 was to break up the data, put it into a scatter plot. I've actually got 2 different sets of data graphed. I've got at the horizontal, this is seconds, time in seconds, starting at 0, going out to 11. The highest data point we had was about 10.3, so we're about here. And then on the vertical axis, I've got distance. So let me ask you a question. Why did I put the data like that and not the other way around? Why would I go distance as a function of time rather than time as a function of distance? Because I could have done that, right? Please, Alicia.
Because when you're going down the hill, it's actually going down.
That's a good point I hadn't thought of. I hadn't thought of that. I was thinking of a more general answer. You got a very good specific answer for me. A more general one, Taryn?
Time as independent.
That's very good. Usually we slap time as an independent variable, usually. But when I asked you guys how fast I was going, what did you say? 12, 20, 8, 3, 7. Miles per hour. You put the distances on the horizontal, on the vertical, and the hours on the horizontal. So you guys yourselves are used to thinking about speed as distance over time. So I just kept with that kind of convention. Although I think it ties into what both you ladies are saying about the conventions of where we place time usually. Time usually is the independent. That the amount you cover in a certain amount of time is up to you. That's a bit dependent. But time itself just marches on 0, 1, 2, and so forth and so on. Is that believable? Fair. So it's kind of hard to see, but there are 2 different data sets up there right now. The red squares, I believe they are the averages. Let me click on one and see if I can tell. I think it is. Oh, that says medians actually. Yep. The red squares are the medians. Behind the red squares, which are kind of hard to see, let me blow it up a little bit so you can see it. Every once in a while, behind one of the squares, see, look, got a little peeking out of there. A little peek, little blue peeking behind there. Those are the averages. So what? A little peek, little blue, little blue, little blue. Oh, right there, he's peeking out a little bit more, right over there. So the idea is, the medians and the averages are very close. The reason I like plotting both of them is if there's an egregious difference between one and the other, then I can decide, okay, why was there an egregious difference? Did I type something in wrong? Yes, I did. You saw me do it a few times. But usually I don't have 40 people watching me type. So I'll screw something up, then later I'll look at it and go like, duh, and then go back and fix it. And the scatter plot is a good way of being able to kind of like have that duh moment kind of practice my own office before I give it to you guys. Sometimes the typos get through, as you found. So anyway, the point being is it doesn't matter if we use the medians or the averages. It's up to you guys, really. Or just use the averages, since that's kind of what we're used to hearing anyway, is the even average. It doesn't matter. They're about the same number anyway. So let's take down some data, okay? Let's take down some data. We're going to make these guys be our x values. So I'm going to copy these over here. Oh, is it already copied them? I think it already is. Am I that smart? I am that smart. Yay, I forgot I was that smart. I actually called them into the other sheet. Yay! So here's the data we're going to play with. Here's the data we're going to play with today. Take these data down somewhere in your notebooks. I'll make a nice and big so you can play with it. Yes, that's what we're going to play with. So this is going to, if it says averages, we're actually going to call this. We're going to put this time. Time in seconds. Oops, not equal, just there. Time in seconds and distance in feet. That's going to be our data. You can ignore this stuff over here. We'll come back to that later on. I think this actually has the function in it. It does. We'll come back to that. Get that out of the way for right now. Yes. That's our data. That's what I want to play with. And as you take the data down, let's start analyzing it right now. Right now. Do you think this data is arguably the same as the uninsured data from last week? Is the same as the Mount Bachelor ticket prices from last week? Is the same as the, if you did it, the Facebook privacy policy number of words as last week and or today, if you turned it in today? Is it the same as the golden ratio that was sort of kind of apparent in our forearms and our arms, wrists from last